Thank you. So I would like to talk a little bit about our experiences from one software project where we had some security problems, and then we decided to do an audit of the security of the project and what kind of challenges we had and how it was from our perspective. Mainly I will discuss a little bit about code, but mainly our problems were about some false assumptions we had about security. And most importantly, our biggest failure was that we were thinking that we are good enough in security and these kind of things. And then we got the certification about 6 months or so ago. So this is not a theoretical presentation, but it's more about my experiences. And as far as I understand, so there are 3 points that are important to do. So we have the process of building applications. Then equally important is the understanding of the developers and the people who are building it. You understand correctly what the security is. And then finally, of course, you must use the proper technology to use it. And I believe that if you have the correct process, so it will help build the understanding, which will then hopefully help use the technology correctly. So then very quickly, since we began, so we maybe didn't have a clear understanding of what is security. So these are some screenshots from a recent WordPress attacks, and that's one of the maybe what we were focused on, that security is when your site doesn't get hacked and doesn't get these kind of messages. But in fact, there's a lot of more, like the public data can be used in inappropriate ways. Someone can scrape the content, send it to a competitor, or can put it on their website. Someone can use our services, their image server, and so on. And if the site gets hacked, so likely the attackers will only get the username and passwords or some personal data, and they try to keep hidden. Probably our site won't get that kind of messages on the front page. Then, of course, there's the theoretical framework of C, confidential integrity and availability, CIA. But then I think that security is more about like the process of discovery. We will never be fully aware of all the security issues. It will never be fully secure, but it's still achievable that we have full security if we just focus on discovering the different security threats. And the process in the certification requirements basically goes to 3 different parts. There needs to be security training, we need to use the correct tools, and we need to do security testing. And these all are basically the building blocks of the process. So the first mistake we had was that we'll follow the waterfall model in the testing. We build the software and then we'll test if there's any security problems or not. But in fact, we're doing all the security mistakes all the time. And in the end, when we started fixing them, of course, there was systematic problems with the architecture and so on. So it's probably better to do the testing all the time and try to identify the issues. Maybe not fix all the potential issues, but at least avoid creating this kind of big mass of systematic problems. So we decided to adapt the Microsoft Secure Development Lifecycle and its agile version, which basically means that for every sprint we do some kind of security testing. And the security tests are put on 3 different types. We have planning tasks, so every sprint we must do some sort of security planning. Then we must verify and test some security features, and then we need to review some decisions we have made and some code reviews. And this way we will have a constant flow of testing. We hopefully will find the systematic errors, but we can still, for each sprint, decide on what are the most important things to test. So the requirements actually allow that you always test the same things every sprint. You don't need to worry, but then it's up to the team to decide. But at least in this way, there won't be a big bunch of testing at the end, and then likely it will be we will be failing them, and then we may be in the situation we were. And then one important point we learned that actually we maybe shouldn't focus so much on repairing the issues we identified. Since then it tended to make the testing something we wanted to put off. Since then we would spend most of the time fixing all the security issues that there could be potentially be. So instead we put them on a bug list or backlog, and then we prioritize them and put them on the next sprints to fix. But at least we got the information, as we won't keep making the same kind of mistakes again. Then from the tools perspective, so basically what they wanted to do, or what they wanted us to do for the certification was that to define an architecture that will be used for all the components. And if there will be a new architecture, so then we need to again write documentation and make sure that everyone who is building this understands the structure we are using. The same with the frameworks and components, basically just identify what you are using. So then the developers won't have that much choice, but at least we can have some code level rules on what to do and what not to do with these components. And then also we identified some security tools we are using to do some kind of testing. And here is a little bit of the screenshot that we have. So basically a very big, like a simple architectural structure, and about 1 or 2 pages description, and then these kind of do not rules for each part of the solution. Then the training was the third part of the process. So as if we define the security as a process of discovery, so then we must train all the time. We are never fully aware of all the issues. And there are 4 parts which we included. So one is information security, like a theoretical knowledge. Then the correct use of the tools, like the frameworks, the architecture we are using. Then in general, secure code principles and the code level use, and then how to do the security testing. And basically, in our plan, we had 1 session every month, so that every developer will give 1 presentation about some topic. And the topics were actually chosen from these OWASP. So OWASP resources. So OWASP is an organization which creates this kind of resources, documents, tools for learning security. As also we had the Microsoft secure development process documentation there. And we just took the different kind of issues from these resources that match the certification criteria and put them on a scale. Then that's basically the process that needed to be done. But then we uncovered we had some false assumptions in security, which we thought we wouldn't, but in reality we probably have a lot of these more. But these are some important points we had. So the first one, I guess many people have found out that one of the causes of security problems is that you go to Stack Overflow and you find this kind of tips marked as the correct answer, which will then just disable all validation. So basically you disable the security, and of course you will not get the error message anymore. So the only way we found to prevent this is that, okay, you can find this, but then go to MSDN or some other official resource to verify what does this actually do. Then one thing we had is that maybe we are doing some sites with some, actually not that important, it's just some documentation site or something like someone gets hacked, gets in and cracks it, so it doesn't matter. But likely there are some usernames or passwords that can be fetched from the database if it's not properly done. Personal data that can be used to to call the employer or maybe call the person with this kind of data. I'm the administrator of this site. Can you please tell me your something? And then also any site can be used to attack other sites. So if you can put some JavaScript on the site, so you can possibly do like a cross-site request forgery, so to make it so that it looks like the person is actually clicking something like a pay button on another site. Or of course the same server may have some other files, or you can access some mail servers through that and so on. So any site this must be secure. And this was one of the things we almost failed in the interviews, as we didn't really understand this properly. Then another one covered in the interviews is that all personal data is important. So again, we were thinking that okay, maybe some personal data is like credit cards and birthdays and so on is more important. But if you think about the legal aspects, so personal data must be secured. And also then some of the business critical information is maybe not so easy to always understand. Like you must discuss with the client and understand what is confidential for this particular client and so on. So for example, in some cases you in some cases the historical data can be scraped and then used in inappropriate ways. But maybe on some other sites it's good to have this kind of historical data available for everyone. Stock levels may be good on some other sites, but then some vendors will want to publicize them. Then one more just minor point is that if it's just like our own super admin user, so I think that okay, maybe we can give it all access to do everything, but actually that is not the case, because maybe there is some problems with the authentication or authorization or anything like that. And probably anyone who has been in IT for a longer time, so if you go check the leaked passwords, so at least mine is on the list. Okay, my password is some friend from someplace. So if I don't remember to always renew them, so then maybe a danger. Then one challenging point was that we do a cloud software which hosts multiple users, so it's used by multiple organizations, and it's called Multi-Tenancy, so that multiple users are using the same database. And this was something we had some problems with. We didn't clearly define that what are the things we must isolate. So for example, email templates, so they are specific to one client, but then our code had them so that they were shared by everyone. And we had also some other issues related to that. Our model was maybe not so clear, so we have accounts which may have multiple users, and each user may have multiple accounts, and each account may have multiple organizations. So maybe this understanding was not shared adequately. So we now try to have a common model for all projects and then make sure that every developer will understand this. I think the reason is that it's, when you start building software, so you start with your own custom software and then you maybe go to some company which builds their own custom software. So this is something that is not so regularly done yet. Then of course there will be mistakes somewhere, so it's important to have multiple levels of defense and security. So I just put an example of TEKES, like the innovation funding agency in Finland, which had some problems apparently in the PDF printing of the system. So my guess is that someone added the PDF printing afterwards. The original team had already built it and accessed the database directly and forgot to make the authorization. So we need to have the user interface, but we don't give any hints on what there might be, what you could access. Then we need to verify that can you do this function and do you have access to this specific data. And then again we do it now on the data access level and a little bit on the database. So we do it's maybe not first performance thing. Maybe doesn't have the best performance, but we do it now on multiple levels. So here's some simple examples of what we do. We check out if you have the correct role. Can we show you this link? Then when you call the function, we make a database call to check that do you have access to this particular data. And then again, whenever we make a database call, so we have a principle to include the user ID somewhere in the code. It will make the SQL commands fairly complex, but at least we verify that there is no way that someone could, by mistake, forget to check the user. Then input points were actually fairly difficult to identify, since that is one of the requirements to identify the attack surfaces. So yes, of course, we will have the form fields, but then we also will have different headers from, for example, the language or the browser. Then maybe we are reading in delivery notifications and storing into the database. So maybe the subject line or something like that could have some sort of injection. Then files, of course, and then even possibly cookies may have changed values. So here is a couple of examples of maybe what kind of problems we could have had. So for example, the HTTP request is basically like a text, and I think that should be important for every developer, no matter how junior, to see that it's basically just written as a text, and you can put anything there. So for example, we had something like input type hidden, and it included the user ID. Luckily that didn't go to any production version, but it's not like it's hidden from the user interface, but of course it can be changed from the tools or even within manually. So basically we have a principle that only move the ID between pages, and they get the most recent data from database. And then user ID must be got through safe tested libraries, in our case Microsoft Identity API. And then since we get the input, which may have multiple kind of injections, so then of course we have the output. And yes, the web page, so Microsoft Framework will possibly take care of it, but then we have something like we are sending email reports. And possibly if we, for example, send that these were the countries the visitors came from. So what about if the so-called country has HTML inside it and a link, click here to verify something. So it may go to an attacker's site. And then of course we may have CSV export, so you may have some code coming from somewhere to go there, and so on. And this, when we started thinking about this, so it surprised us how many different kind of injections we may have. So that's maybe the reason why we thought we were like pretty good in security, because we know, okay, if you write this kind of SQL command, so it's dangerous. But then you can have even some comma-separated values, you export it to some file. So if the attacker knows how we are using the import-export, so he may be able to add a new order line or a new purchase order, something like that. Even CSS can be used to, for example, add the background image that is loaded from somewhere, which will then tell the attacker that, okay, now this person is on this site. And maybe if it's combined properly, knows, okay, now the user is on this site, now let's call him, but we are from the technical support of this site, just on this site, and can you tell me what you see on the page or something like that. So the most important point is just to understand that we must make the inputs as safe as we can, and again, the outputs as safe as we can. So we do the sanitization, try to detect and remove potentially dangerous code, for example, the single apostrophes and quotes. And then we also do for every field validation, for example, even first name, so it must have some rules. And usually there must be some rules, at least the maximum length So it's easy to check if it's done, if there is at least some validation in the code or not. And then when we put it outside, so we encode the data. So HTML coding, or then in JavaScript with the Unicode codes to make sure that it's not executed by accident. And of course there will be again a lot of mistakes. So just some simple examples, like if you try to remove the script tag, so in this example you will remove that one, which will then return the script tag, and it may not be, perhaps it wasn't like thought about by this coder. Or then the variable doesn't have a script tag, but it's actually used inside script. So again, in this case, there may be some problems here in case you didn't validate or sanitize it properly. Then files had some issues. So we thought about saving the database, keep it secure, but then virus scanning was a little bit difficult. Then, of course, we need to save them somewhere else than the public folders that they only are streamed upon request. Also, use of temporary, like one option would be to copy from a save folder to a temporary folder with a random name, but then again, can we be sure that it's removed from that location? What about if there's some problem and it didn't get removed? Then this we haven't actually experienced so much in our cases, but it's just important to note that maybe the file extension doesn't always match the type, and it can be somehow used as an attack. So maybe there is some code which will go and read the code inside the so-called image. And then also, for example, WordPress had some problems recently with the metadata on the images. So maybe the copyright field of the image had some injections and so on. And of course, privacy data. So the camera may have GPS data, or the camera serial number, which can be then tracked to some specific user. But luckily, these are a bit more specific cases. Then one thing we didn't realize that it needs to be like, we need to detect the attack. It's not enough to prevent. It's not enough to have a safe code, because if you have enough time, so the attacker will have the possibility to attack, like in the case of this span properly. It's probably to quite some time, and for some reason nobody noticed. And that was one of the requirements that required us to replan a lot of things, because at least our understanding of the micro framework doesn't support this kind of logging of different security features so easily. So I had to build some custom things here. And then of course what you do when you detect the attack. So there's a lot of different options. Like you can block the user, you can lock the user account, notify them by email. Then one option is of course you make it seem like nothing happens, so the attacker doesn't know that he's getting tracked. Yes, so he keeps trying and trying, nothing happens. So basically the goal is to slow down the attacks, and then we can focus on security, work on those issues. Then we use some testing tools. Of course, they are not so really. They are useful in giving hints where to have a look, and then the attackers probably use those kind of tools to find the easy targets. But in our experience, we haven't had so good experience. They will not reveal many of the security problems. But we use OWASP Jet to do this kind of basic scanning, and then Mozilla Observatory will do some very basic of HTTP headers. And then we have built some custom style code rules to do code level analyze, but it's useful, but it's a little bit complex. And then of course I think this is probably the last one. So it's a minor issue, but if you don't have the information, so it cannot be stolen. So the basic way most password and credential storage systems work is that you generate the hash of the password, and you don't know the original password. And the same way when user logins, so it's again hashed and compared if the two of these match, but you will never know the original password. So if you can, so it's just important to avoid the encryption and then decryption methods, as in this case it can be stolen. Someone gets access to the database and knows the key, so he can decrypt it. But in this case it takes a little more complex work, like testing through different passwords to get the original password. And it seems that maybe this is not so commonly taught in different security classes and so on. So it's just an important point to remind to the team. And then one final thing, even when we got carried away with the security, so we started like coming up with our own different ideas to make it super secure and so on. So I would like to tend that security is like risk management. The bad security will reduce the value the user is getting, but very good security probably won't increase any user value. Of course, in some cases you can create your own solution, it will make it faster, but then in our case we think that we should focus on implementing the best practice of security, but then focus on our innovative energy on something that benefits the user the most.